regression model is given by y is equals to alpha plus beta x. Okay, so remember, this is an estimated model, as I said earlier. So all these are all estimated values. Okay, and y is the dependent variable which you are going to estimate with the variation in the x values. So where beta hat equal to, and I'm just repeating the formula. So summation xy minus sum x into sum y, right? The whole divided by n times sum x square minus sum x all square. Okay, so I'm just going to plug in these values here. So that is 10 times n is 10, summation xy is 8843.6 minus 50.4 times 1602, right? The whole divided by n is 10 times summation x square, so that is 289.54 minus 50.4 the whole square. So this is equal to 88,436 minus the multiplication of these two will give you 8740.8 over 2895.4 minus 2540.16. So beta hat equal to 21.66, right? This is your beta 1 hat. So now we need to get alpha hat, which is equals to sum y minus beta hats into sum x whole divided by n, right? So which is equals to sum y is 1602 minus beta hat, I calculated here 21.66 times summation x is 50.4 the whole divided by 10. Okay, so my resulted alpha hat, when you simplify this, I will get 51.03. Estimated linear regression model is given by y hat equal to 51.03 plus 21.66 times x. So this is my model here. Okay, in other words, the expected calorie in a beer bottle, right? That is equals to 51.03 plus 21.66 times alcohol content in that bottle. Okay, so that's the model has become now. So what does it mean? So when you increase 1% in the alcohol content, right, the expected calorie will be increased by 21.7 times. So that is the meaning of this. So when you increase the alcohol content in the beer bottle by 1%, the expected calorie will be increased by 21.7 times. And if it is non-alcoholic beverage, let's say there is no alcohol at all, 0%, the alcohol is 0%, still the expected calorie is 51.03. Okay, so that's how you need to interpret the values. The number of calories when the alcohol content is 2%. Okay, so you remember your estimated model is this 51.03 plus 21.66, right, times x. So now when alcohol content is 2%, then what is the number of calorie? Okay, so plug in y hat equal to 51.03 plus 21.66 times 2. Okay, so that is equals to 94.35. So now you can go back to the data. So the minimum you can see is 0.4%, right? So that is 70, and the next after 0.4 you see 4.15 is there. So that is 104. Okay, so when you say 2%, so 2% is between 0.4 and 4.15. So when the alcohol content is 0.4, the calorie is 70. When the alcohol content is 4.15, the calorie is 104. So now we are interpolating here. Okay, we are interpolating the value. So what is the value here? The alcohol content is 2%. So that means it comes here, 2%. This comes here, and the calorie is 94.35. So the alcohol content is between here 0.4 and 4.15, 2, right? And the calorie also is between 70 and 104, that is 94.35. So that means your model is working well here. So it is trying to interpolate or predict. The prediction is an interpolation, and it's correctly predicting the values. Okay, this is how we can cross check, right, whether your model is. Sometimes what happens, it might go beyond the limits. Okay, so in that case, you need to whether there may be some problem in the sample you have chosen or the calculation that you made, there may be some problem.